Dear students, welcome. This is our 6th class on simple harmonic boson. We have already done 16 questions on simple harmonic boson. I have written the question number 17. See the question number 17. Show that in a simple harmonic boson of amplitude A and period T, the velocity v at a distance x from the center is given by the relation this. It is a very simple relation. In simple harmonic boson, we have v square equal to mu x square minus x square. Here amplitude is given to be equal to a. V is the distance v is the velocity at distance x from the center. Suppose this is number 1. Mu intensity of force. Time period t is equal to twice pi by root mu. Twice pi by root mu. Twice pi by root mu. Time period t is equal to twice pi by root mu. V square is equal to this. Now from 2 you will get root mu equal to twice pi by t. This means mu equal to twice pi by t whole square. This means mu equal to 4 pi square by t square. Mu equal to 4 pi square by t square. Substitute this value of mu in 1. Therefore from 1 we get. Therefore from 1 you will get v square equal to mu means 4 pi square by t square into a square minus x square. This means v square t square equal to 4 pi square into a square minus x square. 4 pi square into a square minus. It is very simple relation. In this relation, mu has been replaced by t, capital T, in terms of periodic time. Now, the main question is this. Just we have established this relation. Find the new amplitude. If the velocity were doubled when the particle is at a distance a by 2 from the center of force. First, you should find the velocity of the particle when it is at a distance a by 2. What is the velocity of the particle when it is at a distance a by 2 from the center of force? Suppose this is number 1. No, not 1. This is number 3. This is number 3. Suppose this is number 3. Let v1 be the velocity of the particle. Let v1 be the velocity of the particle when it is at a distance. When it is at a distance a by 2. When it is at a distance a by 2 from the center of force. Let v1 be the velocity of the particle when it is at a distance a by 2 from the center of force. Then from 3 we get. Then putting v equal from 3 we will get. Therefore 3 implies. From 3 v is equal to v1 t square equal to 4 pi square a square minus a by 2 whole square. Because velocity is v1, x is equal to a by 2. Putting v is equal to v1 and x is equal to a by 2 in 3. This means putting v is equal to v1 and x is equal to a by 2 in 3. In 3 this we have got this. This means v1 square t square equal to 4 pi square a square minus a square by 4. A square minus a square divided by 4. This means V1 square T square equal to 4 pi square into thrice a square by 4. Thrice a square by 4. This means V1 square T square equal to thrice pi square a square. Suppose this is number 4. This is number 4. V1 square T square equal to thrice pi square a square. When the particle is at a distance a by 2 from the center of force, then if the velocity is V1, then this is the relation. V1 square T square equal to, we have got this one. Now, this relation will be required later on. See the question. If find the new amplitude, if the velocity were doubled, when the particle is at a distance a by 2 from the center of force, let A1 be the new amplitude. Let A1 be the new amplitude. When the particle is at a distance, if the velocity is doubled, new amplitude, if the velocity is doubled, when the particle is at a distance a by 2. Is at a distance a by 2 from the center of force. A by 2 from this line I am writing here. Center of force. The period remaining unaltered. The period remaining unaltered. Therefore, putting here A equal to A1, X is equal to A by 2, V equal to, velocity is doubled, twice V1. Therefore, putting A equal to A1, X equal to A by 2, T remains unchanged, and V is equal to twice V1. Twice V1, velocity is doubled. When X is equal to A by 2, velocity is equal to V1. We have just supposed that this, but according to the question, velocity is doubled. When it is at a distance a by 2, we have to put V is equal to twice V1. When X is equal to a by 2, new amplitude is A1. In 3 we get. In 3 we get. V1, this is twice V1 whole square T square equal to 4 pi square. A1 square is the new amplitude. A by 2 whole square. We have to find A1. We have to find A1. This means 4 V1 square T square equal to 4 pi square into A1 square minus A square divided by 4. Now this 4 will be cancelled. 4 will be cancelled. Now V1 square T square equal to, from by 4 you write V1 square T square is equal to thrice pi square A square equal to pi square into A1 square minus A square divided by 4. A square divided by 4. By 4. Using 4. By 4. That is by 4. That is V1 square. Putting V1 square T square equal to thrice pi square A square. Thrice pi square A square. Putting this. Now pi square will be cancelled. Thrice a square equal to a1 square minus a square divided by 4. This means a1 square equal to thrice a square plus a square by 4. This means a1 square is equal to 13 square divided by 4. This means a1 equal to plus minus root over 13 by 2a. 13 by 2a. Now from the center of force, now you see the new amplitude is from the center of force. If the new amplitude is this A1, this is the center of force. This is equal to root over 13 by 2a, and here also minus root over 13 by 2a. This is also amplitude from the center of force, distance from the center of force to the position of rest. There are two positions of rest. Therefore, the amplitude is equal to this. Therefore, amplitude is equal to root over 13 by 2a. Amplitude is equal to root over 13 by 2a. This is the way. Let us try to solve this problem. Question number 18. A point executes simple harmonic motion such that in two of its positions velocities are u and v, and the two corresponding accelerations are alpha beta. So that the distance between the two positions is this. Also, we have to find the amplitude of motion Let the equation of simple harmonic motion. With center as origin be d2x by dt square equal to minus mu x. Suppose the equation of the simple harmonic motion is this. Also, let A be the amplitude. Let A be the amplitude of motion. Therefore, v square equal to mu a square minus x square, where v is the velocity of the particle when it is at a distance x from the center of force, where v is the velocity of the particle. V is the velocity of the particle. Where v is the velocity of the particle when it is at a distance x from the center of force. Where it is at a distance x from the center of force, let it is number 1 and it is number 2. Now, u and v at two positions, u and v are the velocities of the particle. At two positions, u and v are the velocities of the particle. Now, where I should write, right here, no problem. Suppose this is the center of force. And it is the position of rest. Here, velocity equal to 0. This distance is the amplitude of motion A. This distance is A. At two positions, in two positions, velocities are u and v. Suppose here velocity is u. Velocity is u. And its distance from the center of force is x1. Suppose. Also, its velocity is v. Its distance from the center of force is x2. Distance from the center of force is x2. And the two corresponding accelerations are alpha and beta. Here alpha and here beta. U comma alpha. I have written here u comma alpha. This means at this point, at this particular point, velocity of the particle is u, and the corresponding acceleration is alpha. And at this point, velocity is v, and the acceleration is beta. Now, at this position, the distance of the particle from the center of force is x1, and here the distance of the particle from the center of force is x2. Let u beta velocity of the particle when it is at a distance x1, when it is at a distance x1, when it is at a distance x1 from the center of force, when it is at a distance x1 from the center of force, suppose alpha beta corresponding acceleration. Alpha is the corresponding acceleration, and two corresponding accelerations are alpha and beta, and alpha is the acceleration at that point, and alpha is the acceleration at this point, accelerations at that point. Similarly, v be the velocity of the particle when it is at the distance x2 from the center of force. Similarly, let v be the velocity of the particle when it is at a distance x2 from the center of force. And beta is the acceleration at that point. And let beta be the acceleration at that point. Beta be the acceleration at that point. Now, that is x double dot equal to alpha when x is equal to x1, x double dot equal to beta when x is equal to x2. This means that. Therefore, from 1 we will get. Therefore, from 1, alpha equal to mu x, 1. Take the numerical value. Acceleration is proportional to the distance. Suppose this is number 3. Beta equal to mu x2. Similarly, also v equal to u, when x equal to x1, v equal to v when x equal to x2. Therefore, from 2 we get. Therefore, from 2 we get. Therefore, from 2 we get. From 2 we get u square equal to mu a square minus x1 square. It is number 5. It is number 5. V square equal to mu a square minus x2 square. It is number 6. It is number 6. Now we have to find the distance between the two positions, means x1 minus x2. x1 minus x2. And also in these questions you see v square minus u square. The particle, when the particle is moving in this direction, suppose, the velocity will be increasing. Obviously, v is greater than u. V is greater than u, and acceleration alpha is less than beta. Alpha is greater than beta, and v is greater than u. V is greater than u, and beta is less than alpha. Beta is less than alpha. Now, x1 this distance is greater than x1 distance is greater than x2. x1 is greater than x2. Now, from 6 minus 5 we get 6 minus 5. 6 minus 5 implies, this means subtracting 5 from 6 we get. You may write here subtracting 5 from 6. Simply 6 minus 5 implies, means v square minus u square equal to mu a square minus x2 square minus a square plus x1 square. Plus x1 square. You may write like this. Or v square minus u square equal to mu x1 square minus x2 square. x1 square minus x2 square. Or you may write v square minus u square equal to mu x1 plus x2 into x1 minus x2. x1 plus x2 into x1 minus x2. Suppose this is number 7. This is number 7. V square minus u square is equal to mu into this. Now 3 plus 4, from adding 3 and 4 we get 3 plus 4 implies alpha plus beta equal to mu into x1 plus x2. Mu into x1 plus x2. Using this 8 in 7, using 8 in 7, 8 in 7 we get, using 8 in 7 we get v square minus u square equal to mu into x1 plus x2. For this you may write alpha plus beta into x1 minus x2 into x1 minus x2. This equation will be required later. U square equal to mu into a square minus x1 square. This means x1 minus x2 equal to v square minus u square divided by alpha plus beta. What is x1 minus x2? Distance between the two positions. Therefore, distance between the two positions is equal to this. Therefore, distance between the two positions, the distance between the two positions equal to v square minus u square divided by alpha plus beta. Therefore, we have proved part 1. We have proved part 1. Now, 3. Equation number 3 is alpha equal to mu x1. Beta is equal to mu x2. and u square equal to mu into a square minus x1 square, and v square equal to mu into a square minus x2 square. If you write the equation of simple harmonic motion is d2 x by dt square is equal to minus mu x. Put d2 x by dt square is equal to alpha. Then you will get alpha equal to minus mu x1, beta is equal to minus mu x2. Then the answer will come in this form x2 minus x1 equal to x2 minus x1 equal to v square minus. You must write here v square minus u square, not u square minus v square, because because v is greater than u, v is greater than u here. Therefore, here you would get x2 minus x1 equal to this one. x1 minus x2, x2 minus x1 will be equal to this. Means the distance between the two positions will be equal to this. So there will be no problem if you write like that also. The numerical value of acceleration is mu into x1. Now you see accelerations are alpha. Now you see second part. We have to find the amplitude of motion. Now you have to find the amplitude of motion. Means you are to find the value of A. Value of A in terms of alpha, beta, u and v. You are to find the value of amplitude, means A in terms of alpha, beta, u and v. From these four relations, you are to express A in terms of alpha, beta, u and v. Alpha, beta, u and v. Now, from 3 and 4, 3 square minus 4 square. Squaring 3 and 4 and then adding we get alpha square minus beta square equal to alpha square minus beta square is equal to mu square into x1 square minus x2 square. x1 square minus x2 square. You will get this one. It is up to 8. It is 9. Suppose this is 9. This is alpha square minus beta square is equal to mu square into x1 square minus x2 square. Now, from 5 and 6, v square minus 6 square. 6 minus 5. 6 minus 5 implies v square minus u square equal to v square minus u square is equal to mu a square minus x2 square minus x square plus x1 square. This means v square minus u square equal to mu x1 square minus x2 square. Suppose this is number 10. Just eliminate x1, x2. Ultimately, you have been given 4 relations. 3, 4, 5 and 6. You are to eliminate mu x1, x2, and you should express A in terms of alpha, beta, u and v. Your aim is this. Now, from 9 and 10, if you divide 9 and 10, then x1 square minus x2 square will be removed. Dividing 9 by 10, 9 divided by 10 implies, means dividing 9 by 10, you will get alpha square minus beta square divided by v square minus u square equal to mu square x1 square minus x2 square divided by mu x1 minus x2. This means mu equal to alpha square minus beta square divided by v square minus u square. V square minus u square. Suppose this is number 11. Suppose this is number 11. Now, you have to find the value of a in terms of this. From 5, you 5 implies from 5 you will get. From 5 you will get u square by mu equal to a square minus x1 square. A square minus x1 square. Now from 3, x1 can be written as alpha by mu. From 3, this is number 12 suppose. From 3, x1 equal to alpha by mu. This means x1 square is equal to alpha square by mu square. Alpha square by mu square. Therefore 12. From 12 you will get. Putting this value of x1 square from 12 we get. Therefore 12 implies u square by mu equal to a square minus alpha square by mu square. Alpha square by mu square. You will get this. Or a square equal to u square by mu plus alpha square by mu square. Alpha square by mu square. You will get this one. In the numerator it is u and in the denominator it is mu. It is mu. In the numerator u, denominator mu. Now you may put the value of mu here from 11. From 11 you may put the value of mu. This means a square equal to u square by mu. Mu means alpha square minus beta square divided by v square minus u square plus alpha square minus beta square whole square divided by v square minus u square whole square. This means a square equal to u square v square minus u square divided by alpha square minus beta square plus alpha square v square minus u square whole square divided by alpha square minus beta square whole square. Now let me write the equation. Here, mu equal to alpha square minus beta square divided by v square minus u square. This is 11. Now, from this you will get v square minus u square divided by alpha square minus beta square whole square. Alpha square minus beta square whole square. You will get here u square into alpha square minus beta square plus alpha square into v square minus u square. You will get this. This will not be work this time. Now, this is equal to v square minus u square divided by alpha square minus beta square whole square. Alpha square u square minus beta square u square plus alpha square v square minus alpha square u square. You will get this one. These two terms will be cancelled. These two terms will be cancelled. And you will get v square minus u square divided by alpha square minus beta square whole square. Alpha square v square minus beta square u square. You will get this one. This means A equal to. This means A equal to alpha square minus beta square. In the denominator you will get this, and in the numerator v square minus u square into alpha square v square minus beta square u square. This whole to the power half. Whole to the power half. V square minus u square. Alpha square v square minus beta square u square whole to the power half divided by this. You will get this one. You will get this one. Therefore, amplitude of motion is this. Therefore, amplitude of motion is this. Amplitude is equal to, and in the numerator alpha square minus beta square, v square minus u square, alpha square v square minus beta square u square under root. This is under root or to the power half. Now you see, using 3, 4, 5 and 6, you should express A in terms of alpha, beta, u and v. At the same time, you should eliminate x1, x2 and mu. x1, x2 and mu. Now, we have applied these 3 and 5. Now, from 4, now you see, from 4, you may find x2 equal to, x2 square is equal to beta square by mu square. x2 square is equal to beta square by mu square. And you may put the value of x2 square in number 6. In number 6 also. In that way also you can find the value of A. And you will find the same result. A is equal to this. Let me write the yes, no. Very important no. You may verify this one. From 4, x2 square equal to, you will get beta square by mu square. x2 square is equal to beta square divided by mu square. x2 square is equal to this. 6, from 6 you will get v square equal to mu x square minus beta square by mu square. You may write like this. Beta square by mu square. Or v square by mu equal to v square by mu, this is equal to a square minus beta square by mu square. Beta square by mu square. Or a square equal to v square by mu plus beta square by mu square. Now using 11. Now 11. Using 11. Put the value of mu. Yeah. This means a square equal to v square by mu means alpha square minus beta square divided by v square minus u square plus beta square divided by mu square means alpha square minus beta square whole square divided by v square minus u square whole square. V square minus u square whole square. You may write like this. Now, this means a square equal to v square into v square minus u square divided by alpha square minus beta square plus beta square into v square minus u square whole square. V square minus u square whole square. Here it is alpha square minus beta square whole square. Alpha square minus beta square whole square. You may write like this, which is equal to alpha square minus beta square whole square, and v square minus u square. You may write like this, v square into alpha square minus beta square plus beta square into v square minus u square. You may write like this, or v square minus u square divided by alpha square minus beta square, alpha square minus beta square whole square. It will be alpha square v square minus beta square v square plus beta square v square minus beta square u square, beta square u square, beta square u square. Or this is equal to v square minus u square alpha square minus beta square whole square. These two terms will be cancelled and it will be alpha square v square minus beta square u square, beta square u square. This means A equal to alpha square v square minus u square alpha square v square minus beta square u square. This whole to the power half. A is equal to this. The amplitude is equal to alpha square v square. Now in this way you can find the value of A in terms of alpha, beta, u and v. The amplitude, in this way we can find the amplitude of motion. Let us take one more problem. Let us try to solve this problem. A particle rests in equilibrium under the attraction of two centers of force which attract directly as the distance. Their intensities being mu and mu dash. The particle is displaced slightly towards one of them so that the time of small oscillation is twice pi by root over mu plus mu dash. Let A and A dash be two centers of force. The two centers of force. Let A and A dash be two centers of force. Let A and A dash be two centers of force. The intensity of A is mu, intensity of A dash is mu. Their intensities being, mu and mu dash respectively. Their intensities being mu and mu dash respectively. A particle of mass m be in equilibrium at the point B. A particle of mass m be in equilibrium at the point B due to the attractions of these two forces. These two forces of these two centers of forces. Due to the attractions of these two centers of force. Now force of attractions. Force of attraction at B. Force of attraction at B. due to the center of force A, force A is equal to intensity mass M, intensity mu A, where AB equal to A, where AB is equal to A. AB equal to AC, AB equal to AC. Also, force of attraction at B due to the center of force A dash equal to M mu A dash, M mu dash A dash, where A dash B equal to A dash. See, where A dash B equal to A dash. It is in the direction BA. Attraction along, you may write here, along BA. It is along in the direction BA dash, opposite directions. But the particle is in equilibrium at the point B due to this centers of attraction of these two centers of force. Therefore, due to equilibrium, this should be equal to this. Due to equilibrium, M mu A equal to M mu dash A dash. Due to equilibrium, M mu A equal to M mu dash A dash. This means mu A equal to mu dash A dash. Suppose this is number 1. Suppose the particle is slightly displaced to the point towards A. Suppose the particle is at B and the particle is in equilibrium. Suppose the particle is slightly displaced towards A, towards one of them, towards A, suppose towards A, and thus let it be released, and then let it be released. It be released. Let it go. Then let it go. Let P be the position of the particle at time t. Let P be the position of the particle at time t, where BP equal to x. This BP, this distance is x. A dash B, it is A dash. BA, this distance is A. BP is equal to x. Now, at the point P, now force of attraction FP due to the center of force A. Force A, this is equal to mass M, intensity mu. Distance is AP into AP, which is equal to M mu. AP means a minus x along p that is in the direction of it is x, that is in the direction of x increasing, that is in the direction of x increasing. That is in the direction of x increasing. Also, the force of attraction at P due to the center of force A dash. Now, let me write here. Also, the force of attraction at P due to the center of force A dash. Due to the center of force A dash. Due to the center of force A dash equal to m mu b p a dash, which is equal to m mu a dash plus x along p a dash, that is along, that is in the direction of x decreasing, in the direction of x decreasing, in the direction of x decreasing, that is in the direction of x decreasing. Hence, by Newton's second law of motion, hence by Newton's second law of motion, the equation of motion of the particle motion of the particle at P is given by equation of motion of the particle at P is given by mx double law d2x by dt square equal to, just write the increasing portion here, a minus x minus m mu, here the intention is mu dash, you should write here mu dash into p a dash, mu dash here, m mu dash a dash plus x, because intensity of the center of force a dash is mu dash, right here mu dash. Or you may write d2x dt square equal to mu a minus x minus mu dash a dash minus mu dash x. You may write like this. Oh. Mu a minus mu x minus. You may write like this. Mu a equal to mu dash a dash. Now mu a equal to mu dash a dash. Therefore, now mu a is equal to mu dash a dash. Therefore, from this you may write d2x by dt square equal to minus mu x minus mu dash x, since mu a equal to mu dash a dash by 1. This means d2x by dt square equal to minus mu plus mu dash x, which represents a simple harmonic boson, which represents a simple harmonic boson with center at B, with center at B, at B, with time period equal to twice pi by here intensity is mu plus mu dash. Therefore, this represents a simple harmonic boson with time period this and this. Therefore, we have solved this problem also. Dear students, I want to stop here. Thanks for attending the class. Thank you very much.